Unit 11C, Introduction to the Student T-Distribution. T-curves look a lot like standard Z-curves, but have thicker tails. This is the Z-curve, standard normal curve, whereas the T-curves, and there are infinitely many T-curves, have thicker tails. We identify a T-curve by degrees of freedom. Degrees of freedom is one less than the sample size. As degrees of freedom get bigger, T-curves start to look like Z-curves. So, for example, if this is a Z-curve, if I have a T-curve with degrees of freedom 10, it might look like this. On the other hand, if I have a T-curve with degrees of freedom 20, might look like that. You can see that the degrees of freedom 20 curve is closer to the Z-curve. These are T-curves. In fact, when degrees of freedom get to be close to 30, the T-curves start to look very similar to Z-curves. Here's an example. For the T-curve with 2 degrees of freedom, find the critical value of T that has a right tail of 5%. So in this case, this particular curve has degrees of freedom 2. This area is 5%, this tail, and we want to find T critical, sometimes called T sub 0.05, the critical value of T with a 5% right tail. How do we do that? We can use the T-distribution table. The table looks something like this, usually, depending on the book you consult. But we have the degrees of freedom in this column, and we have the area of the right tail in this row, and in the body of the table we have the critical values. So in this case, we had 2 degrees of freedom, we had a 5% right tail, and if we go down that column and across this row, this is the critical value of T. If we do that on this table, we had degrees of freedom 2, and the area of the right tail was 5%. If we go down that column and across this row, we get T critical is 2.920. You could also do this on the TI-84 if you press second distribution number 4, inverse T, then you put in the area to the left. So if we go back to the picture we had a 5% tail. The table requires the area to the left, which would be 95%. 95%, 0.95. So that's what you would put into the area. You have to enter the degrees of freedom, 2, and then hit paste, and you'll get something like this, and hit enter again, and you'll get T critical. So there's T critical, which is about 2.92. Same thing we got before. So this is our picture, therefore, of the problem. We had degrees of freedom 2, the area of the right tail 5%, and this was the critical value of t.